So in our previous video tutorial we got a tin that we were pretty happy with, and so if we want to take this tin now that we're done editing it and creating it to our satisfaction, we would like to convert this to a raster DEM. Rasters turn out to be a lot more flexible in terms of the number of things that we can do with them, and so it's helpful to get out of this tin-based format and into a raster format because there's a lot more spatial analyses that we can do with rasters. And so to do that, we're going to go to Arc Toolbox and we're going to go into our 3D Analyst tools and we're going to go to Conversion, okay? And then we're going to go from tin, and then it's tin to raster. And one of the things it's going to ask us is how do we want to, or what resolution do we want to make that raster at? And so if we were to zoom in here, how are we going to make that judgment call? Well, one of the things that we can look at is our average point spacing. So we could use the ruler tool, for example, and say, okay, well, points look like they're, let's see, so that was 0.89 meters. If I look at some of these, well, those 2 points are only 30 centimeters apart. Well, those points are 2 meters apart. Those are 1.5 meters roughly. Right, so I've got these different, this very variable point spacing. So maybe something around a meter would be a reasonable starting point to try this out at. And so if we go into that tin to raster command, I'm going to use my tin 3. And then it's going to ask, where do I want to save that? I might go ahead and just put this in my Pat's Cabin topo. Now I'm going to call this DEM, and then since I'm doing this at 1 meter, I'll say 100 centimeters for the name here. And I'll go ahead and save that in there. This definitely wants to be a floating point so that we have the decimal points. Remember, the elevations are in meter, and so if we do it as an integer, it would only be plus or minus a meter. You can play with the difference between linear and natural neighbors. I would suggest you use natural neighbors as the method for interpolating from the tin to the raster. The reason is that it calculates the cell values by using natural neighbors interpolation of the tin triangles, and we've found through experimenting that tends to be a better representation. But in this sampling distance, what we want to make sure is that we choose a cell size explicitly, and so the syntax here is cell size, and then we're going to do that in meters, so 1.00 meters. And we'll go ahead and click OK. It'll take it a second to create that raster, and then it adds it in underneath, in this case, the tin. So I'm going to turn off the tin so I can see it. And so here's the entire raster of that reach. And although the raster shows us something, it's I can see already from this that 1 meter may be a little bit on the coarse side. It's a little bit pixelated in terms of what it's showing me. And so your job is going to be to look at several different resolutions. I believe I suggested 5 centimeters, 10, 25 centimeter, 50 centimeter. This is your 1 meter, and then I would do a 2 meter, a 5 meter, and a 10 meter. And so you're going to do this conversion for all of those, and you're going to look at the differences between them. Now, one of the problems when we convert to a raster DEM, this isn't an overly helpful way of displaying the data by itself, and so it'll help us if we derive from that raster, go to raster surface in the 3D Analyst tools, a hillshade, and if we derive from that DEM what I'll call HS for hillshade of the same resolution, we model its shadows, we keep the default sun azimuth angle and sun altitude angles, and we click OK. This will derive us a hillshade for that reach. Okay. And just like we saw in task 1, we will change this well, let's change this so that the DEM is on top of the hillshade and it's transparent, and then let's change this to a color ramp that looks a little bit more like elevation. And then we see our representation of the reach, and this looks pretty reasonable. Okay, it's still a little pixelated, but that's going to be the exercise that you explore on your own in terms of deriving these DEMs at different raster resolutions and making a suggestion to your boss as to what is the most appropriate size. Remember, doubling the resolution. So if I just say, well, I'm going to go from 1 meter to 50 centimeters, does not double the number of cells and double the amount of work for any raster operation. It squares the number of cells. So if I had 10 by 10, I had 100 cells, I would be not going from 100 to 200. I would be going I would square 100, so I would go up to 10,000 cells. Okay, so those are decisions that you should take into account when making the suggestion to your boss. Higher will definitely resolve more features, higher resolution, but it will also increase the computation time. Okay, so bear that in mind, and that concludes this particular video tutorial.